Hello, welcome back. So I got those two nice industrial toolroom machines, a Deckel FP1 milling machine and the Weiler Primus lathe. Both replaced machines that I had for a fairly long time. The Optimum MB4 milling machine, truly a hobby class machine that I pressed into service for doing some fairly tight tolerance work, and the MCRO Super 11 lathe, a machine that I would consider a premium hobby machine or a minimum viable industrial machine. I will get to that term later. It has nothing to do with the actual quality of the machine. This video will be a bit different, mostly talking, but I will augment it with videos and images. So maybe think of it as a machining podcast with slides. Also, this is the first time me writing a script, so please go easy on me. Let us start with the milling machines, because the Optimum MB4 and the Deckel FP1 are very different machines. The MB4 is your classic hobbyist benchtop machine, about 350 kilogram in weight and fairly large travels. Significant larger travels than the FP1, that is almost double the weight of the MB4. The MB4 is a wet noodle in terms of stiffness, but within its limitations, it's a good working overall system. Just don't expect it to run a 20mm end mill or a 63mm face mill for anything but light cuts. It really shined with good carbide end mills up to 10mm in diameter. What is really nice about the MB4, it's a really good drilling, tapping and boring machine. About 120mm of quill travel, easy to use quill stop, and also it's quite easy to add a linear scale to the quill for depth measurement. Also, the option to quickly change between fine feed and regular rack and pinion feed is very nice and worked very well. The FP1 is in its core a horizontal milling machine that got a vertical head with a quill later in its design phase. The quill is short, it has only 60mm of travel, has no depth stop, no fine feed, and the bearing system of the spindle itself, running in the quill, is on the complicated side and rather expensive to rebuild. On the bright side, it's a very compact 40 taper head, very rigid bearing layout, and within its short travel, it's very good at drilling. The quill lock of the FP1 in its final iteration is a very elegant design that cannot be over tightened, and it does not influence the position of the quill when locked. Overall, it's two very different machine concepts, both with pros and cons. That's also why the part on the milling machines in this video is way longer than on the lathes. There's just more to say about them. Complexity. The FP1 is a mechanical, complex machine. No doubt about this. Everything is driven off one motor. The horizontal spindle, the vertical spindle, table X and C feed, and the coolant pump. That means there is a lot of moving elements in this machine. The amount of gears in the machine frame is almost comical, but it's also a very clean and compact design while maintaining a certain rigidity. The ability to remove the rigid table and mount whatever you want onto the vertical apron improves greatly what you can do. The machine might have fairly small travels, but it can handle fairly large parts. Meaning, while you cannot do full machining on a large part, you can easily work on large parts. Imagine boring and milling a feature on a large casting bolted to a vertical table, or boring the eye of a large hydraulic cylinder. That's work that can easily be done on a FP1, despite the machine being fairly small. All that capability is something that the inherent complexity of this machine brings to the table. Pivoting to the MB4, out of the box, that's a very simple machine. It has, as the FP1, only one motor, but that one motor is only driving the vertical spindle. There are no other components driven by it. The gearbox is entirely contained in the vertical head that can be tilted, but to be honest, the tilting of the head on the MB4 kinda sucks. It's very top heavy and quite painful to set, therefore. You can add power feeds to this machine, but that's usually a aftermarket solution, very similar to a Bridgeport power feed, or you have to DIY something with an auxiliary motor like I did with a slow spinning DC gear motor. On the bright side, since it's a very simple design and a very simple machine, there is less things that can go wrong. There is no complicated gear train in the machine column that will cause you to tear out your hair when something breaks. Lastly, build quality. I kind of dread this topic a little bit because it's very easy to fall into a bias. The MB4 is a Chinese machine and has corners cut at every possible corner, to a point where you end up with a circle. I don't want to badmouth it, since it served me very well for a long time, but you have to be realistic about a machine that's in the low four figures when bought new. As an overall system, it was surprisingly accurate. The only thing that I had to do was to shim the column into squareness, but the rest was okay out of the box. Especially the spindle runout and the ever important quill-to-quill bore clearance were of zero complaint from my side. Squareness and straightness of the XY table was of no concern either. Over the years I did some work to the tapered gibs because their fit was kinda atrocious, and I rescraped the X and Y axis. Was the rescraping really necessary? Yeah, not really, but I wanted to do it for my peace of mind and because I thought it's neat. I never did any work to the Z axis. For the remaining build quality, well, it was fine. It needed, I tore it down right away and deburred everything and recut a lot of threads just to get dirt from production out of the bores. But that's common practice with rather low-priced machines. The FP1, on the other hand, build quality is of no concern. Everything you touch is well made, but you deal with a very old design with some design decisions that we might call silly today. The lubrication system, the main spindle bearings, the hard-to-access coolant tank, and some more. And B, probably a used machine with all the wear and tear you would expect. I bought my FP1 from a rebuilder, but it was a used, not recently rebuilt machine. When I looked at it, I checked the overall geometry with a straight edge and precision square and looked for obvious trouble. At the time I noticed that the y-axis would need a bit of work at some point in time, and that the horizontal spindle taper would also need some attention because it looked and appeared a little bit bell-mouthed, which in the end turned out to be true. Scraping the y-axis. A common problem on these machines is that the y-axis will wear on the table-facing end, since it's easy for dirt and chips to migrate into the way and cause damage on top of the regular wear. The FP1 does not have wipers in this position, and by default there is also no way guard for the y-axis. So I made a custom y-axis guard that keeps almost all dirt away from the exposed way. It's currently a 3D printed part with a piece of neoprene covered fabric. This is a commercial available way cover material. After doing some measurements, I decided to scrape the y-axis both on the column and the actual slide, so both sides need to be scraped at the same time. On teardown, I noticed that the wear was very distinct in the front and the back of the column ways. The center was unharmed. That is because the center was relief scraped. That's a very common practice in rebuilding. You scrape the entire way for full bearing and then relieve the center for a few microns. That ensures that the slide doesn't start to rock when the ways wear in a concave pattern, which it always will. With the bluing you can see this relief in the center even better. Here you see me taking the first heavy passes with the BX power scraper just to knock down the majority of the material. It took me 2 passes before I used the straight edge for bluing the scraped surface for the first time. The cardboard and the blue masking tape is there to keep chips from falling into the open-topped gearbox. One very important part of this process is checking the geometry. Scraping in isolation is relatively simple, but checking the geometry is usually the hard part. In my case here, the alignment of the y-axis itself is important. So I'm checking the y-axis against the x-axis, so it's traveling square side to side, and then I check it against the z-axis using a precision square. You want the y-axis on these machines to raise a few microns when extended out to its full travel to account for droop due to gravity, even more when you add the vertical head to it, and also to account for future wear. After that, you need to check the orientation of the horizontal spindle. You use a test bar for that. It also needs to be squared to the z and the x-axis. It's a little bit of back and forth to get this right, but it's very important. If you don't do that, for example, drilling with the horizontal spindle is utterly painful because the drill will always rub with its flutes on the wall of the fresh bore, and you will never get a good drilled hole that way. When scraping the slide, I used a 1-2-3 block and 2 carbide pins to measure the width of the dovetail over the length of the slide. I prefer this method over using a large micrometer. Since I already had everything apart, I also took out the horizontal spindle to check the bearings, clean everything, and re-grease them. They consist of needle bearings that run directly on the spindle without an inner race. The adjustment in the radial play is done by changing the needles in a 2 micron size increment. Decal rebuilders will have those rollers available. Mine were fine, no action needed. The end play was fine. This is let's say, it's a controversial design choice. On one hand, it allows for a very compact, very heavy load bearing spindle design. On the other hand, they are complicated and expensive to rebuild. If the bearing surfaces are damaged, they need to be sent out for cylindrical grinding, and they will never run as round as a spindle running in angular contact bearings. That's just by design. As usual, it's a compromise, as all things in engineering and in life. I can't go into too much detail because I honestly didn't document it very well, but I can tell you that it's the thing that you might have to deal with when you get a used old industrial machine. These machines were at the time expensive and meant to earn their money. Wear was unavoidable, and maintenance usually was like 5th priority. The cases where you can buy a unicorn of a machine that has rarely been used and has always been maintained properly and taken care of, those cases are far in between. What I also can tell you, doing this without a crane would be rather unpleasant. The y-axis slide is not particularly heavy, maybe 25 kilograms, but you need to finagle it a little bit to clear the large gear on top of the column, and that's not too much fun when you have to lift the slide above chest height and move it into place without damaging anything. Reboring the bell-mouthed spindle. At first I was planning on using a grinding spindle on a ball bearing slide, but I couldn't find something suitable or viable at the time, so I was looking for alternatives, and the alternative was the compound slide of my lathe, since this was rebuilt when the machine was rebuilt. I dropped the compound into a vise on the indexing head. That's quite a tall stack up, but it worked quite well in the end. This allowed me to set the angle of the compound slide for boring very accurately using a sine bar. Center height could be set with the vertical axis of the mill. As a side note, center height is absolutely critical for precise taper boring. The boring itself was done with a CBN cartridge insert that I just welded with 316 stainless filler rod to the side of a piece of 16mm round stock. My regular inserted boring bars were too short or not stiff enough to hard bore the taper. I ran the fine feed that I made for another purpose, and the result of the bored taper was rather good. Until I commit to a full rebuild, I think this will serve me very well. I set up the electronic indicator here to check the TIR of the spindle, and the probe amplifier is set to 10 micron full reading, so 0 to 10 micron, and I get a full reading of 2 micron when running the spindle slowly. So that's a rather good result, and that's within the limitations of the spindle. One important factor, familiarity. Is the FE1 the best machine for my line of work? Probably not. But is it the best machine for me? Yeah, probably. From the first year of my apprenticeship up until I left my day job, I always did work with and around FP series machines, and I know them and their capabilities in and out. That's a huge factor. Less fact-driven, but just as important for me. Also, it's a piece of German industrial heritage. Other companies build similar machines that are, from a technical standpoint, definitely the better machines. Better slideway construction, better lubrication systems, even better materials in some cases. Example would be Maho, Sixes, and Schaublin. But I like the FP1 with all of its flaws, its quirks, and its outdated design. That's why it is the best mill for me at this point in time. As a tangent, I can show you two Deckel FP1 milling machines in odd places. The first one is a movie, James Bond, the man with the golden gun. We get to see a gunsmith shop. Right at the entry, we already get a Bowley lathe as a first treat. When Roger Moore is aiming downrange, we can see a Deckel FP1 and the oxy-fuel setup along with a forge in the center of the picture. The FP1 could also be an Alexander toolmaster, since large portions of the movie were filmed in the UK, and Alexander being a UK company doing a license or a copy build of the FP1. While 007 is obtaining some information from Lazar, the gunsmith played by Marn Mayland, we can also see an XL number 2 die filer. I really wonder if this was a real shot that the production rented for filming, or if they just threw a few things into a set. The second is a very real place, the Lawrence Livermore National Laboratory Plutonium Facility. There is a semi-famous picture of a Harding HLVH in a glove box for machining parts or samples out of fissile materials, so namely uranium and plutonium. If you look very close, you can see something in the background. Yes, that's a Deckel FP1 milling machine. I went a bit on an online search then and found a document on the Lawrence Livermore National Laboratory Plutonium Facility where you can see the entire glove box area from a bit more distance. The glove box to the right holds the FP1 mill. The long glove box to the left holds the Harding HLVH. There is a video called Stockpile Stewardship, How We Ensured a Nuclear Deterrent Without Testing, where you can see a bit more from those glove boxes. Here's this shot where you can see a Heidenhain Metro height gauge right in the center of the picture on its granite base stand. And in the background, there is again the FP1, this time from its backside. The tangent on those two machines did add absolutely nothing useful to this discussion, but I absolutely needed to tell you about it, or otherwise I would have exploded. I will link the sources for both the James Bond scene and the Lawrence Livermore lab down in the description. What would have been the alternative for a toolroom mill? I could have replaced the Optimum MB4 with a Failmon mill drill. It's basically a Swiss-made round column bench mill in really good quality. Well made, ball screws in X and Y's, nice integral linear scales in the XY table, excellent tooling quick change system. Just overall a very, very handy looking machine in marvelous good build quality, and you can still buy them new. Failmon will happily sell you a Picomax manual mill drill. It's mid 5 figures. But yeah, you can get them. In hindsight, it might have been the wiser choice for the small work I do. It has a faster spindle, it has a better quill, the quick change tooling is really nice, but it lacks a little bit in the stiffness department, making it overall less universal for my around the house and my personal project needs. For example, if I do modifications on my own machines. I don't run very large tools that often, but it happens. Large saw blades, using the UPA3 boring head, fly cutting large radii, things like that, or just drilling big holes. Those things always were a little bit limiting on the MB4, and I suspect from looking at it that the Failmon would be similar-ish. It would be stiffer because the build quality is overall better, and fit and finish of mating surfaces directly affect the overall stiffness of a system. But overall, I think it would be a nice secondary mill, but not my primary machine. And in another alternate universe, I would have a Bridgeport. I think they are really neat machines, simple and very elegant in their overall design. The hard-chromed quill and the option for hard-chromed ways seem like a very good call. The long quill just looks like great feature. I really adore the Bridgeport design overall. It might have its limitations and drawbacks, but so does every machine and every machine concept. So I think they're cool machines. But they're rather uncommon here in Germany, and the footprint of a Bridgeport it's really big, especially if we want to make full utility of the RAM and the turret. With the lathes, it's a little bit different to the milling machines. The Super 11 and the Weiler Primus are very similar laid-out machines, pretty much like any normal toolroom lathe. So the difference in performance and approach to work will not be as striking as with the milling machine. The Super 11 is in my mind the minimum viable industrial toolroom lathe. It has the features of a larger, heavier machine. It's very precise and well made, just not as heavy and rigid. It is still a machine that you can move with 2 persons and a strong breakfast. For the work that I did and I do, it was an absolutely viable machine. Why do I call it a minimum viable industrial machine then? Because EMCO cut some corners in odd places. The entire cross slide and carriage assembly has no provisions for any kind of lubrications besides squirting some oil on the ways and dovetails and move the slides back and forth. The result of this with the felt wipers is questionable at best. It's like they designed a really, really good headstock and gearbox, then just run out of money for the rest of the machine. Furthermore, for the size of the machine, it is built a little bit light. It's almost double the center distance of the Weiler Primus and has a significant larger center height, while only being maybe 50% of its weight. A little bit more probably. I will put the real numbers on screen. The compound slide on the EMCO kinda sucked. I think it's too weak built for this machine. That's why I ran a solid tool post 100% of the time, and I just mounted the compound if necessary on the back of the cross slide. That said, with a solid tool post, the EMCO is able to take surprisingly heavy cuts and deal with fairly wide form tools or use cutoff tools without causing too much trouble. Accuracy of the MCO was really good. Both straightness of a part, meaning the taper, and roundness never caused me trouble. I had parts measured for roundness and they came out in the 2 micron roundness range, which for a normal lathe is quite good. So that was really never an issue. A funny quirk about the MCO, the last stage between the motor and the spindle were straight gears, and on very fine finishing cuts you can see the harmonics from those gears telegraph into the finish. Not measurable with any of my equipment, but on a very fine finish you could see it in the right light. The Weiler has a double V-belt between the gearbox and the spindle, so this does not occur here. The belt dampens most of the mechanical noise away from the spindle. On the other hand, the gearbox on the Weiler is louder. It's always a trade-off and compromise. There is a reason why you see the Super 11 lathes often in R&D shops or maintenance departments. Sometimes just augmenting a larger lathe for fine detail work or as a general purpose machine. They are very good machines. And also they seem to wear quite well, despite the absolute horrendous lubrication concept on all the slideways. The Weiler Primus that I have now, on the other hand, is substantially more rigid. The bed has a larger cross section, is very heavily H-ribbed compared to the diagonal ribs on the MCO bed. The boxways are super beefy. And while it also doesn't have central lubrication, it has oil fittings, oil grooves, and oil passages on all the vital elements. So maintaining the machine is generally easier. The headstock on the Weiler is beefier. It runs larger tapered roller bearings, and the spindle interface is the next size up. That's not only important for rigidity, but with it being a standard DIN 55027 size for short taper, that's the same taper as on a cam lock, but with a different mounting system. The advantage of that is that you can just buy a off-the-shelf backplate or chucks with an integral short taper 4 compared to the short taper 3 that MCO used. That is, well, it is a standard, but really hard to get these days. So I usually machine those for the MCO myself, while I can just buy backplates for the Weiler. So a conclusion was changing the machine. Was changing the machines really necessary? In both cases, mill and lathe, no. But the familiarity with both the Decla and the Weiler machines from my former day job career made them a natural choice. Let's start with the mill again. I usually don't have to think too long about how to solve a setup problem on the Decla, but to be honest, some things are slower than on the Optimum. With the Optimum, I had it set up to keep 1 or 2 vices permanently on the table, and all accessories like indexing head, rotary table, or an angle table would just drop down into a vice. That was extremely fast and usually stiff enough. This has become a bit slower process on the Decla, just with the accessories being rather heavy and usually requiring the crane to handle them. I could do the same here by keeping a rigid table of Kurt Weiss on the machine at all time and just drop accessories in there, but I think that's a sad thing to do with such a versatile machine. The strength of the Euro 2-room mill comes from its adaptability, the existence of a vertical and horizontal spindle, and that very large vertical apron that you can just bolt accessories and parts to. So I might have dropped a little bit of speed for almost unlimited versatility. So I might have given up a little bit of speed for a very versatile system and the overall joy of using the machines. Also, it's nice to not have to be overly concerned about machine stiffness. The FP1 brings plenty of that to the table for my line of work. Oh, and tapping on the decal is slower since it has no spindle reverse. Yes, I could just hook up a reverse switch or do a VFD conversion, but both of those take time to do properly. Until then, tapping is a little bit slower since I have to manually crank the tap back out. For the lathe, the Amco and the Weiler are very similar machines, and for the quality of my work, it doesn't really make a difference, but the Weiler is usually faster. It's stiffer and has way more torque on the spindle. That makes roughing larger parts way quicker. I would hesitate to take on customer work above 30 or 40 millimeters in steels with the Amco if large material removal was required, since it would bog down very easy. Not an issue with the Weiler, it will just rip down material. I want to do a final, that's the better machine. I'll leave that to your conclusion if that's important for you, but keep in mind it's always about compromises. For me, I'm happy with my decisions here. Before I end this video, I need to get something off my chest. The last few months, when you browse the YouTube search results or the recommended videos, you will get a larger amount of video essays on technical topics, all fairly long and with a decisive title like How a German Camera Designer Invented the Machine Tools That Armed the Luftwaffe, or The Forgotten Machine Tool Capital That Powered America's World War II Arsenal, or, a fan favorite, Lathe versus Mill, a 200-year rivalry across two world wars. To make it short, they are AI-generated slop. The narration doesn't match the imagery in large part. The images often are just random semi-related pictures scraped from the internet or entirely AI-generated. And the number of views they get, well, it's kick to the face for anyone who puts actual work in his videos and is not taking shortcuts with generative AI tools for script narration or even picture and video content. Even worse is reading through the comments, because those videos cater to a specific everything in the back used to be better nostalgia that people tend to fall for. You, the viewers, have to decide what you prefer. I won't tell you what to watch or what to consume. That's up to you. But what I can tell you is that humans will slowly stop sharing what they love to do and what they're interested in when the view count and the interaction on human-made content goes down. And as a consequence, the black box called the algorithm will serve you more and more AI slop, because if this is what gets more interaction, well, the algorithm knows what you like. The platforms have a large share in creating and cultivating this problem, not only with the algorithm and the search function now being algorithm driven, but also not enforcing a clear labeling of AI-generated videos. Yes, there is a marker on YouTube for AI content, but you have to basically use a loop to see it. The search engine on YouTube is getting worse and worse by the day. That doesn't help either. It will rarely spit out search results that are word by word to the search term. It's now algorithm driven and will serve you in essence a mess. At least we still have a working subscription feed. So if you're still here and watching, thank you so much for sticking with me. I won't lie to you that I don't do these videos out of monetary interest and strictly for the fun of it. It's advertising for my business, a small trickle of YouTube AdSense money. Please use an ad blocker. Watching ads is not worth your time. And the money from Patreon. That makes it viable for me to take several hours a month out of my day to work on these videos. It's fun for me to produce these videos. It's basically the hobby part of what I do now. Also, I love sharing what I learned over the years and still learn every day. I know that a lot of you love to see project builds, machine improvements, and machining of complex parts, but with my current workload, I have the problem of finding time to tear into machines that I depend on For example, imagine if I had to tear apart my lathe to do a major improvement project on it or modification project, but I need the machine to actually make parts for customers that wait on their part. And also more and more of my work cannot be showed due to NDAs. That's why I tried something new with this video, mixing some history and thoughts on different machine concepts and also giving a little bit of a retrospective on changing or switching from hobby machines to industrial machinery. So I hope you enjoyed. Thank you all for watching. Thanks for the support, and I'll be back.